chilling on the weekend, no. Met you through some friends of friends of friends, and those my people, so I knew that you was down, so down to give a freaky yo. Pull up and go smoke out a blunt inside my vehicle, crazy.
This is the concept video for integration with partial fractions. So these techniques are for integrals of the form with the integrand like f of x equals some function p of x over q of x. And throughout this I'll be using this example. We'll be looking at the integral of 3x plus 11 over x squared minus x minus 6 dx. And if you look at this real quick, you'll notice you can't really do a u substitution here. If we set u equal to x squared minus x minus 6, our du would be 2x minus 1 dx. And I can't find that up there. I don't know about you. So that's not going to be the way to go for these problems. So to show you how this is going to end up being, you can actually separate this into two different terms, 4 over x minus 3 minus 1 over x plus 2 dx, and from there these are pretty simple to integrate. This is just 4 times 1 over x minus 3, which is going to be ln of x minus 3, absolute value, minus ln of x plus 2, absolute value, plus c. And as some substitution rule, like if you didn't get how I got that, then try looking at those videos. So what this video is going to be concerned with is how do you get from this to this. So I'm going to give you some steps. Step 1 is going to be factor the denominator. And I'll be doing these steps as we go along. So I'll be doing this without the integral sign. We're just going to decompose this fraction to begin with. So you can see that this bottom can be factored into x minus 3 and x plus 2. So that's step 1. Step 2 is we're going to need to identify the types of factors. Alright, so step 2, the different types, we have linear, so in the form ax plus b, and we have quadratic, ax squared plus bx plus c. And then we need to also identify if we have any repeat factors. So if we have repeat linear, they'll look like this: ax plus b squared. And then if we have repeat quadratic, ax squared plus bx plus c squared. And we need to look at the type of decomposition term we're going to get for those. So for linear, let me move all this down a little bit to get some more room. So for linear, for linear, our decomposition term is going to be like this: a, which is some constant, we don't know what it is yet, over ax plus b, our linear factor. For quadratic, we're going to have ax plus b, and this a isn't going to be the same as that a. It's just we don't feel like using different letters until we actually do the problem. If these are both present, you'd use a up here, and then probably b here and c here. And I'll show you like in our example. So we're going to have something linear on the top, capital AX plus capital B over our quadratic, which is AX squared plus BX plus C. And then for repeat linear factors, for every time it's repeated, this is actually going to be to the n power, n being however many times it's repeated. But let's go with squared for now. We're actually going to have to do some constant a1 over our linear factor, ax plus b, and then some other constant a2 over ax plus b squared. And if that doesn't make sense, I'll show you in the example video how that works. And then for quadratic, we're going to have a1x plus b1 over our quadratic factor plus a2x plus capital B2 over our quadratic factor squared. Alright, so seems a bit confusing, but let's look at our example and see what I mean. So we have 3x plus 11 over x minus 3, x plus 2. So we have two different factors in the bottom here, and they're both in the form ax plus b. Lowercase a being 1 in this case, b being -3, lowercase a being 1 here, lowercase b being +2. So we're going to set that equal to some constant a over our factor. And instead of using a again, we'll use b over our other constant factor. So that's all we do in this step. It's a lot of words here, but this is essentially all that happens. Step 3 is to give the right side a common denominator. So that common denominator is going to end up being the one on the left side. So the way you do that is you multiply a by the factor it's missing on the top and bottom, because we're essentially multiplying by 1. Same with b. It's missing x minus 3, so we're going to multiply the top and bottom by x minus 3. These have the same denominator now, so we can combine the numerators. So there we go. Next step, since these denominators are equal, we can set the numerators equal to each other. So 3x plus 11 has to equal a times x plus 2 plus b times x minus 3. And now, next step, multiply out the right hand side. So we want to distribute this a across now. So ax plus 2a plus bx minus 3b. And what you want to do is, wherever you see an x, you want to group those together. So you have ax plus bx, and then all the constants we also want to group together. So 2a minus 3b, and then preferably we can factor out these x's. So we have a plus b times x, and then we have this group of constants, 2a minus 3b. This all has to equal 3x plus 11. And that is our Our next step is to set the coefficients equal to each other. So you'd set your x squared coefficients, your x coefficients, and your constants equal to each other. So in this case, 3, what is happening here is this 3 has to be equal to a plus b, because a plus b is multiplying x on this side, 3 is multiplying by x on this side. So they have to be equal for the equation to hold. So 3 has to equal a plus b, and this 11, which is a constant on that side, has to equal this group of constants on the other side. So 11 has to equal 2a minus 3b. Alright, and now we go back to some algebra. We solve the system of equations. So I'll go through this pretty quickly. A is going to equal 3 minus b, and we can plug this in to our second equation. So 11 is going to be equal to 2 times 3 minus b minus 3b. 11 equals 6 minus 2b minus 3b. Subtract 6 from both sides, 5 equals negative 5b. Combine those two terms and solve for b. B equals negative 1. And then we plug b back into our original equation. A equals 3 minus b, which is negative 1. So a must be 4. So now, next step, plug in values of a, b into the decomposition. So for that, we have to go all the way back up to here. And we're going to plug in A and B. So I'll rewrite it here. So this equaled A over x minus 3 plus b over x plus 2. And a was 4, so we'll put in 4 here. B was negative 1. And now we do the integral. So integral of this side has to equal the integral of this side. Or put a minus out here. And the integral of that, as we did before, it's just a substitution. And there we go. So that is integration by partial fractions. And I'll do an example in the next video.